Hello, everybody. How you doing? I see Chip, Jaleb, Mark, Jim, Tom. Welcome, welcome. Don't forget to like the stream, everybody, so that YouTube pushes it out a bit more. Hey, Ixella? I'm not sure how to say that. Tom, if you have a request to change the members list to say something else, you can let me know on Discord. But it just uses your YouTube name by default. Hey, David, how you doing? And Ice Cube. Hey, Eric. I still see you as Tom C in chat. Unless that's not your real name. I talk to Asylum every once in a while. He's doing fine. He's getting a lot of sleep. That's what he told me. Recharging. All right. So this puzzle is called Fibonacci 16. It's by wooferzfg. And this was Woofer's first puzzle, which is pretty awesome. We've done a bunch of especially collabs that Woofer did with I think Jaleb or Jacob, not Jaleb. But this one was Woofer's first puzzle, so that's awesome. There he is. All right, so we have normal Sudoku rules. In addition, place the following digits, the first 16 Fibonacci numbers, not including zeros, in order anywhere on the yellow cells to form a path. Each digit on the path must be on one of the 8 cells that is adjacent to the previous digit on the path. The path is allowed to cross itself, but cells may not be repeated on the path. So we're going to be placing 1, 1, 2, 3, 5, 8, 1, 3, 2, 1, etc. Should be visible on screen. So yeah, the path can go diagonally. Interesting. Okay. So I think we probably have to start with Sudoku just to get an idea of where digits can go. We got to start with 2 1s. So that's got to cross like here, for example. Or here. Like it's got to cross into 2 boxes, 2 rows, and 2 columns. So I'm going to look at where 1s can go first. See if we can get anything out of that. The 1's here. 1s go over here. So is there only one set of diagonals that you can actually place 1s in? So let's see, 1s can go in this row. It needs to be 2 consecutive rows. So we need 1s in these 2 rows. But that doesn't work because they're in the same box. So I think it's only these 2 rows that can even get 1s. So let me unhighlight anywhere that's can't be a 1. So that one doesn't have a diagonal. Was I given a bet cell? Let me check. Where's my key? Right, I need to give you links as well. Row 2, column 9, thank you. Yeah, I see it here too. Here's our bet cell. I had these highlighted. All right, I'm a little all over the place. I think that's everything. Did I pin it? I did not pin it. Okay. Now I think we're good. So this feels like the place to start, but we could really cross anywhere here with ones. Hey, Panthera. How you doing? We can't start here because we wouldn't be able to go up. So we're either crossing here or we're crossing somewhere around here. So let's highlight those green. That's probably hard to see. Let's try blue then. That's better. So yeah, and that's true. There's 3 3s in a row. So how are we going to do that? Camera angle's normal, but let me see if I can fix the capture here. Maybe I'll do this. How's that look to you guys? Oh, I'm a little bit uncentered. Row 1, 2, column 3, 4. True. Yeah, you can. Yeah, I was even just looking at these rows. Oh, true. You can put them diagonally across. Yeah, so you can put them diagonally across boxes. But let's take a look at where that's actually viable for these 2 rows. You know, maybe I should be looking at where I can put 3 3s in a row instead, because that's the most limiting. So let's see. I need to. So that does have to cross into. You have to do it somewhere like here, where you can go. How would you do it? Like this? It's not here, but where you can cross 3 boxes, 3 rows, and 3 columns. So it's going to be. This is the first 3 rows where that would work. But there's already 3 in that row. So let's highlight all the rows that don't have a 3 yet. Oh, crap. I lost my highlight. This row and this row. Are these the only rows without 3s? This row needs a 3. Okay, so there's only one block of 3 rows that's even missing 3s. So it's these 3 rows. Can't put 3s here. So that's not going to work and that's not going to work. This diagonal won't work because we'd stay in the box. There's 3 there. That's a 2, 4, 6, and a 1. So let me mark those blue real quick. I can't turn back on myself because that doesn't use 3 columns. So this one doesn't work. Can't do this one because it can't get out of the box. This one doesn't work either. We got to start on the bottom. So we're either doing this or this. Those are the only choices. So these don't work. So am I doing 3, 3, 3 like this or 3, 3, 3 like this? Ah, can't do it here because there's a 3 in the box. So I think we found where our 3s go. Very nice. Now, can I finish the 3s? There's a 3 in one of these two. There's another 3 on the path. There's 2 more 3s on the path. 3 more 3s on the path. Yeah, it's true. After the 3s, we have 7, 7. So there's only... Well, there's 2 ways we could do that. But the 7's going to go here. Well... No, we could go here as well. I'm going to actually draw the path like this to make it a bit more clear. Whoa, why do they go across the... Can I not start in the center of the cell? I can start in the center, so good. I'm going to draw the path like that instead of coloring. I should use a different color, though. Maybe I'll color and draw it? I don't know. Let's do purple. There we go. Right, there's a 7 in this box already. So if I put a 7 here, I would have nowhere to go with a 7. So I could put a 7 here or here, which would then follow up here or here. Right, there's a 7 here already. True. In fact, isn't the 7 just placed? That 7's placed. And then this is 4, 5. Okay, so we have to eat a 7, and there's only one 7 to eat. So we take that 7. Now that has to bounce down here, because there's a 7 in this row. Oops. Then after the 7 is 6, 1. So we can't go down. We can't go here. We can't stay in the box. So 6 has to go here. And then wherever the 1 ends up in this box is where we end. This is just where the 7 went in box 5. There's a 4 in one of those two. So now before the 3 is a 2. That seems hard. I think I have to put it here. So of all these cells... no, I could go down. I have 2 options for the 2. So there's a 2 in one of those two. Puts a 2 up here. After the 2 is a double 4, though. And from here, I can't do a double 4. So I gotta go up. So where am I doing double 4? I could go left and up, or I could go up to here and here. I think there's options. There's only 2 placed 4s. Sudoku in my Sudoku puzzle? Can't go left, you say? Can't go straight up, that's true. But I could go left and then diagonal. Well, hold on. If I went straight up, couldn't I go here? Oh no, there's a 4 in this row. Right, there's a 4 in this row, so I can't go left. And I can't go down here. Okay, so let's... Of all these, obviously we're not going into any of those. I can't go left because there's a 4. There's a 4 in the row. This wouldn't be able to go anywhere. And if I go straight up, I wouldn't be able to continue with another 4. So I think I have to take this 4 next. And then there's only one place to go with another 4, which is here. Draw that. And now I need a 1. One of these 3 is a 1. And that's where it continues. This is a pair. This is a 1 and a something. 1 and a 5. Could be worth filling 5, 7, 8, 9 here. Yeah, the 7 goes here. 7 up here. How about the rest of this box? Derek says I'll find a naked single. 5, 7, 8, 9. Yep, that's an 8. These are not 8s, that's not a 7. 5, 9 pair puts 7 here. There's an 8 in one of these two. So now we have a triple. This is a 3, 4, 8. We kind of knew that for the column, so that's okay. 3, 4, 8 triple. Okay, so yeah, we can do this triple on this pair. We need 2, 5, 9. The 9 is placed. And we need 1 and 6. So from here, we have the 4. We're working backwards. We need a 1 and then a 9, 8. So if I put a 1 up here, I don't think I can get to a 9. Because this row can't have a 9. And this row can't have a 9. Well, I guess I could go 1, 9 just like that. I can just go straight left. Never mind. Let's fill these 4. 5, 6, 8, 9. But then the 8 is broken? True. If I went 1, 9 across here, where would I put the 8? I don't think there's an 8 that could go in any of these cells, because this 8 and this 8. Well, this 8 doesn't matter. But yeah, the rest are filled with non-8s. True. So I think the 1 has to be here. So I'm going to put a 1 here. And then I need a 9. It could be here or here. But from here, I guess I could do 8. Actually, it looks really nice to go 1, 9, 8, 5, 5. That looks really nice. In fact, if I go down, do I get stuck? Feels like I get stuck. Okay, well, we can't go down anyway because there's no 8 there anymore. So we got to get an 8 from somewhere, and then a 9. So, sorry, a 9, then an 8. So I think we go 9, 8 like that. Sudoku helps. We need a 4 and 6. So there's only one 5 to grab here. So we'll grab this 5, and then there's only one place to get 5 from here. We'll grab that 5. And then we need a 4. There's only one place to get a 4, which is here. That resolves these. And then we need a 3 and then a 1. Maybe there's more Sudoku. Let's fill all these. 6, 8, 9. Yeah, those are done. This is a pair. 2 and... Okay, so the 2's placed. 2 and 4. And then this triple is 1, 5, 9. So we know the order. I'm just going to Sudoku as much as I can here. I need a 1, 3, and then whatever's left. 4. Need a 1. Oh, this is just filled. It's a 5. This is a 7. 1 or 7. If I just pencil all these, I think it'll help finish the path. I need a 1, 2, and 3, it looks like. So we know the order. Well, kind of. Okay, the path has to go through here. We'll never resolve it. So we have 1, 2, 3. We need 4, 5. The 4 and 5 are placed. And then we need 6, 7, 8. So the 6, the bet cell was a 6. Okay, and I guess the line finishes the deadly pattern. So from the 4... Wait, where were we? This 4? Yeah, we had 5, 5, 4. So we need a 3 and then a 1. So we're going to take this 3. It's the only 3 we can get that has a 1 after it. But now there's... finish the puzzle, but I need to finish the line. 1 followed by 8. Followed by 5, 3. 2, 1, 1. Well, I see a way to do it. 3 followed by 8, 5, 3, 2, 1, 1. Nice. So we have 1, 1, 2, 3, 5, 8. Wait, I missed a 1. There you go. 5, 8, 1, 3. No, wait, what? I missed something. All right, let's fix this. I missed something. 4, 3. I need 1, 2, 3, 1. Is there only 1, 1, 1 that I can grab? There's 2 of them. Okay, so I've got the 3, and then 1, 2, 3, 1. 1, 2, 3, 1. That traps me though? Oh no, I get the 8, then the 5, then 3, 2, 1, 1. There we go. So 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, and then we got to finish it here, 61. 761. I don't know if I read those numbers right, but nice. Cool. Nice puzzle. Thanks, Woofer. Yeah, having the Sudoku resolve before you finish the whole path. That's okay. It happens. Alrighty. Let's do the next puzzle. And I should say that Woofer was a super supporter, which is why he skipped the queue, and Sotek's also a super supporter. So Sotek is also skipping the queue. Alrighty. This puzzle is called Digit Blender. It's by Sotek. We have normal Sudoku rules, standard arrows, and palindromes. So on arrows, digits on an arrow sum to the value in the circle, and palindromes are the same forward and backwards. All right. This is at least 5. One thing I'm seeing is that, these sum to the same as these. Same here. So we're kind of transposing the arrow down into these columns. So I'm wondering if we should add all of these together. These add to at least 20. But yeah. Which means that these add to at least 20. That's not hard. Yeah, the given 1 and 2. Hey, zetamath, welcome. So I'm being told to look at 8s in column 1 and 2. Yeah, I've been doing well. We have 19 on the arrows. So what's wrong with 8-1 here? Forces a 1. Ah, I see. So we can't put a 1 on this palindrome because it forces a 1 in one of these two. A 1 can't go here because it transposes here. The 1 can't be a sum on an arrow. So we can't put an 8 in these cells. Or these cells. Solver feature request, give the ugliest 2-cell thermal that makes this grid unique. So, does that limit 8s enough to be interesting? Okay, because 1 can't go on the arrow, it is minimum 2, 3, so it's at least 5. That's true. Derek suggested I color, I assume, the palindromes? Sure. So where is purple in column 3? Well, we know purple's not 8, so purple's down here somewhere. Ah, but it can't go here, so this is purple. So then this is blue, which goes here. The color's been in my heart the whole time. So blue is, yeah, at least 3. Right, so blue can be replaced by these 2 cells. So this circle is these 2 cells plus blue. Sorry, these 2 cells plus purple, and we know they can't be purple. So it's at least 6 now. Yeah, not too far yet, Sotek. So I guess I could give 2 different colors to this. We can give this green and orange. That's orange, that's green. Or do we want to repeat this first over here, where should we prove we can't put 7 on here? Is that a thing? 7 would go with 1 or 2. Right, this cell can't be 1 or 2. So if 7 went with 1 or 2, it would have to go here, but this also can't be 1 or 2. So you can't put 7 or 8 on here. I think that means you can't put 7 over here either. Oh no, 7 would work. No, purple can't be 1 or 2, and this can't be 1 or 2. So we can't put a 7 on here either. So actually, purple is from 3, 4, 5, 6. So anyway, we can give different colors to these now. We know they go down here, which go up here, so they're different than blue and purple. So we'll do green and orange. And they go down here. Do we know which is which? Yes, this cannot be green. So this is orange. This is green. Again, green is 3, 4, 5, 6. And orange is also 3, 4, 5, 6. Is blue from 3, 4, 5, 6? I worry that blue can be 2. No, blue can't be 2 because of it's on the arrow sum. So blue, we found our 3, 4, 5, 6 quadruple, basically. So these cannot, yeah, so if we don't put a 2 on here, we can't put 1, 3, 4, 5, 6 either. There's definitely a 2 on here. So it's got to be 2, 7 adding to 9. So this is a pair as well. This is 8, 9. True. These arrows add to at least 10, which means these two add to at least 10. So I can't include a 3 or I can't get to 10. Which means that, so let's do that for all the blue. So those can't be 3, all of the oranges, those can't be 3, which means green can't be 6, and purple can't be 6. Alrighty. What's J-Lib's point? Row 1, column 8. Oh, right. We know that these arrows sum to 3, 4, 5, 6, which is, so it's going to be 2 9s. That's what that's going to do, because they add to 18. So this is one way to sum to 9, and this is one way to sum to 9. That's the way to put that. This sells at least 3, which means this sells at most 2. At most 3. Well, actually, can we put a 3 on here? I can't put a 3 here, because it would have to go with a 1 or a 2. So this has to be less than 3. No. Yeah, because 3, 4, or 5 would have to be 1 or 2. So this is a 1 or a 2. Pink circle's a bet cell. It doesn't affect the puzzle. You just bet what you think the value is going to be. And then same here. This is a 1-2 pair. And so this is 3, 4, or 5. So is that. But if it was, so that means that these have a color. This is not purple or green. So this is blue or orange. And if it's blue or orange, it can't be a 3. So, but I can't put blue on its own arrow, so it is orange. So this is not orange. We already knew that. Could be green, purple, or blue as far as I can tell. Ah, this can't be 4 anymore. And this can't be 6 anymore. Ah, so that makes this the 4, 5. So this is 6, 3. I believe. So we don't need that color anymore. It's interesting that the 6, 3 resolved, but the 4, 5 didn't. This cell here can't be a 5. Hey, Jessica. Yeah, if this were 4, then this would be a 1, making orange 5, making this also a 1 to add to 6. So that doesn't work. So that's the 3. 3 with 2 would add to 5. 5 would go with 1. 3 with 1 would go to 4. 4 would add with 2. That all works. Green 4, 5's over here somewhere. Maybe these arrows are useful now. I need green in this row. So green's up here. This adds to at most 8. This is 1, 2, 3, 6, 7. Not a 6. This is 1, 2, 3, 6. Not 6 or 7. I guess this is only 1 or 3. Interesting. Can't be 2. Can't be 4 or 5. Can't be 6. Can't be 7. This also maxes out at 8. So these are from 1 through 7. 3 and 6 are gone. 3 and 6 are gone. This sees a 4, 5 pair. But this one doesn't. Could be green. This arrow can't add to 7 now? True. We could add to 3. No, we can't add to 3. Can't add to 4, 5, 6. A 7 sum doesn't look possible because we can't do 1, 6, 2, 5, or 3, 4. So it actually must be 8. So how are we getting to 8? Either 1, 7 or 3, 5. We can't be 3, 5. So it is 1, 7. Wow. There was only one option for that arrow. So this can't be 3. Could it add to 4? Based on our candidates, it can't, because there can't be a 3 over here. It could add to 5. Can't add to 6 or 7. It could add to 8. Now, how would we add to 5, actually? 1, 4 only? But that doesn't work. If we tried to add to 1, if we tried to add to 5, how would we do it? We could do 1, 4. We can't do 2, 3. So we'd have to be 1, 4. But that would mean green is 4. Because we only get 1 of 4, 5 over here, and it would be green. But if green was 4, and then this was 5, then that would mean orange is also 4. So we can't actually add to 5. It has to be 8. Now, how are we adding to 8? 1, 7 works. We can't do 2, 6. Can't do 4, 4. We can't do 5, 3. This is also 1, 7. And this is the green 4, 5. That was really cool. I liked that. Those arrows do a lot of work. We still haven't resolved the 4, 5. Okay, what's the next question to ask here? I guess Ice Cube's telling me I should do this column. So we have 1, 2, 3. We need the other 4, 5. We need 6 and 8. So 8 has to go here. So 6 up here with a green. So this is a green 6 pair. And the green does not go here. So this is the green 4, 5. And this is the 6. Being told there are many 7s I can put in the grid. Well, yeah, there's one here. There's a 7 over here. There's a 7 up here. There's a 7 right here. And here. So we're down to, yeah, we're down to just this X-wing on 7s. This should be a pair. We have 1, we need 2. The 2 goes here. And the 9 goes here. This is 3, which goes here. And 6. Here, this is orange with something else. Orange 8, 9. So, oops. Let's see. Green goes here in this box. And here. And here. Is that all the greens? That's all the greens. Orange in this box goes down here. I don't think I can do much with oranges yet. I'm being told to look for 9 in column 3. Yep, indeed, that's a 9. So now we know there's an orange up here. Does that help? Yeah, X-wings with these oranges. And we have an X-wing on oranges here. Unfortunately, pink circle cannot be an 8. I think 1, 2, 4, 5 is what's left here. Ah, yes, 8 can be placed here. There's an 8 up here. This is orange and something else. Orange and 1. This is a triple. 1, 2, 3, it looks like. Huh. I'm glad you'll keep it on the down low there, zetamath. Let's see. Oh, I need a 1, 2 in this. Okay, I need another 1, 2 in this column, which goes up here, and then I need a 3 in the column. So the other 1, 2 with the 3 in this column goes here. Okay, I found a hidden. You're tired, Rubik's? I'm told that falling asleep to Sudoku streams is really nice. I've done that before. Let's see, 6 and 9 down here. You can place them. There's a 1, 2, 3. That's a 2, 1, and 3. All right, now we're making progress on our Sudoku. Yeah, me too, zetamath. I think that's a great service. Have I fallen asleep to my own Sudoku stream? I may have once or twice. I've definitely fallen asleep to a lot of CTC videos. Let's see. The numbers are hypnotic. Let's see, 1, 2, 3, 4, 5, 6, 2 and 6. Okay. Know the order. Ha! We now know that orange is 5. Orange. I should just click them. Orange is 5. Green is 4. Two, 3, 4, 5, 6, 7, and 8 go here, so that's not the 8. Yeah, keyboard typing is soothing as well. That's a 9. 1 goes here. Then we need a 5. And this is a 9. Oh, up here as well. I need a 2 and a 6. Very nice. Thank you, Sotek. I enjoyed that. That was cool. Some neat deductions in that one. Do I need to do an ASMR Sudoku stream? All right. Now we go back to the top of my queue. Please don't. It was the same way we colored the right side, so I'm sure it was intended. Alrighty. This is called Look and Say Arrows by Derektionary. So we have normal Sudoku rules. Numbers outside the grid are look and say clues. They describe what numbers are on the diagonal. For example, if a clue says 3, 4, then there are 3 4s on that diagonal. So there's 1 5 in there's 1 5 on this diagonal. The arrows in the grid are look and say arrows. The digit on the arrow's tip says how many times the digit in the arrow's circle appears on the cells after the arrow's tip. Okay, they are all a diagonal. So the digit on the arrow's tip, so let's say this digit were 2, says how many times the digit on the circle appears. So let's say this was 5. Then this would be saying that in these cells, we have 2 5s. So there could be a 5 here and a 5 here, for example. Then nothing else would be 5. ASMR arrow sandwich min-max Renban. All right. Well, how do we get started on this? I think what we could do is look at every single one of these tips and say how many times you could possibly repeat. So 1, 2, 3, 4, 5. So this doesn't exceed 5. 1, 2, 3. This one doesn't exceed 3. This one doesn't exceed 4. This one can't be more than 2. Same with this one. Aha, so then this one has to be 3. So that means that this cell is repeated down here somewhere. And then this one has to be 4. So this cell, and this cell are the same. Let's give those green. Be sure to feed and walk your pet variant regularly and have it seen by a Sudoku vet at least once a year. If one constructor in the community was the Sudoku vet, who would it be? Ah, so now we know that this green repeats at least twice. So this is not a 1. You think zetamath would be the Sudoku vet? Jovi. I was going to say Philip Newman. Jessica said Philip Newman as well. Tallcat? Tallcat would be going to the Sudoku vet. Does the Sudoku vet only care for camels? Glum Hippo goes to the vet. True. Also, hey Rocky, how you doing? Well, it can't. Well, wait, hold on. We know that green is in one of these two. But this could be green, couldn't it? Well, okay. If this was green, it couldn't be 4. Or 3. Green by definition. Glum Hippo Goes to the Vet is the new children's book. I'll mark that one of these is green, so we don't forget. Yeah, 4 of these cells are green. Oh, so then that means this is green. Right, okay, that's green. So then here, we're going to see at least 3, but we could see 4 greens. So this is 3 or 4. Green can't be 4. It's in the same box as a 4. Okay, since green can't be 3 or 4, it can't be here. So this is green. And now this is a 4. There we go. Progress. And we haven't even done all the tips yet. 1, 2, 3. This can't exceed 3. This can't exceed 2. There's a 1-2 pair in this column. That makes this a 3. So now, if we call this purple, right, green in box 9 goes here. If we call this purple, we need 3 purples. So one of these is purple. That's purple. One of these is purple. So purple is 3. So I guess I don't need... I'll keep the purple for now. Whatever color this is goes here, here, and here. Yeah, so that means this is purple. Good point from Sotek there. So this is purple. How about this one? We can have 1. We can have up to 2 here. So yeah, that's a 1, 2. Then this one, that can be up to 4, but it can't actually be 3 or 4, so it's a 1, 2. I feel like coloring 1, 2s might be helpful. We know one of the 1, 2s is green, actually, so these are all 1, 2s. So we can give another color to the other 1, 2. So I usually do green, purple, but I can't. So yellow, not yellow, blue. That's blue, that's green. So that's blue, that's green. Blue's down here somewhere. Green in box 1 is up here, true. And that's all the greens. Could this really be 5? 1, 2, 3. I don't know why I said this could be 5. Definitely maxes out at 4. If it were 4, then this cell, one of these, Ah, it would have to be blue. Okay. Oh, so that doesn't work. So if this wants to be a 4, then we need this diagonal to have 4 on it. So it would be blue. This would be blue, but oh no, that does work. But it means blue is one of these two. That's what that means. Because either this is a 1 or a 2, which makes it blue, or this is a blue 1 or 2. Which means blue is 2, then this is blue. Ah, that doesn't work though. So if this is a 4, I'd have to put a blue here, and I couldn't. Which means this is the blue. Okay. Got it. Wow, how does this... Oh wait, we have all these outside looking says, which I haven't touched. So there's a 7 here, and there's a 7 here. There's an 8 here and an 8 here. 1, 2, 3, 4. These are all 4s. Oh, sorry, there's 2 4s, not 4 4s. Oh, what am I doing? Two of these are 4s, not this one. Two of these are 5s, so there's a 5 up here, and there's a 5 down here. There's 2 6s in these cells. So if this was a 6, this would have to be a 1, which is blue, by the way. One of these two is a blue. Is that helpful? If this was blue, blue would be 1, and we put a blue here. Being told there's a... Laszlo says 3 in box 9. True. Just purple. I think I looked at all of the diagonals. Oh, there's 1 5 on the main diagonal. Okay, if row 5, column 1 is blue, then we need at least 1 blue on this diagonal, which would go here. So this would be blue, this would be 1, and that would be blue. Ah, but it can't be. Wait, hold on. Neither of these can be blue because of this one blue here. So this cannot be blue. This is blue. And now we have to put a blue up here. It's the only blue on this diagonal. So blue is 1. Darn it. Blue is 1. Green is 2. So 1 down here. Nice. So I don't think I need these colors anymore. At least not those ones. Let's get rid of that too. So this appears twice. Let's reuse a color here and make that blue now. So it has to go in those 2 spots. Hey, Afraid Not, how you doing? row 7, column 7. Ah, so this cell has to appear here, and one of these two. We can at least call these orange. And one of these, orange could be, oh, orange is not blue. So orange is here. So here's a column with blue. And a row with blue. Orange in column 1. Oh, orange in box 7 is in one of these two. If this was orange, then it would say only one of these is orange. So we know those aren't orange already. We know that orange isn't 1. Yeah, I usually end this stream with Wordle games in about, well, see the time above my head? It's at 9 usually. So. Hey, J-Man. Box 3, box 3 orange is in one of these two. Which points in and places this orange. So there's an orange down here. And there's an orange in one of these two. And there's an orange in one of these two. Ah. Wait, orange could be 4, couldn't it? Does anyone to prove orange isn't 4? Not really. Ah, no, wait. Yeah. Orange has an X-wing down here, which sees one of them sees going to see a 4. So orange is not 4. And we know orange is not 1. Because of here, at the very least. So these point up. That's an orange. Oh yeah, orange just shares a box with the 4. That's the easy way to put it. So if this is orange, it sees 1 already. So this would not be orange. So we put an orange here and here and here and here. So that's one option. Yes, using the X-wing logic is clearly better. Saying it the simple way doesn't help viewers learn. There you go. I'm trying to teach advanced techniques. All right. Well, 4 in this row, is that? No, I can't quite do 4 in this row. 4 in this box is in one of these two. 1 in column 9. Ah, cool. Or box 9. That's a 1. That places this one. We should be able to place the one up here. Yeah, the one up here is here. And I think that's all the ones. Nice, ones are done. Can the 24 diagonal be done? I don't see how. Ah, this 4 looks up. I see. These two are 4s. There we go. That's a 4. Guess there's a 4 on one of these. What about the 6s? 2 of these are 6. Not helpful. I don't have any 6s placed. All right, orange is not 4. We know that. So 4 is in the same spot as these 3s, making a 3-4 pair. That's a good spot, Jim. Derek's walking his dog. Blue's in one of these two. We know it's not 1. What 3's in this box? Because we know blue is not 3. I guess it's in one of these 3. Yeah, blue's not 1, 2, 3, or 4. Okay, so either this is a 6, which just fulfills automatically the 2 6s, or it's not a 6, which means that of these, we have 2 6s and a repeat. So is that an issue? Welcome back, Derek. I don't know what to do with that, though. There must be some way to get these high digits. I mean, it really, I feel like these diagonals are meant to give us the high digits. Yeah, I don't see what to do with that immediately, but... Anything I can do with 3s? Guess one of these is... wait, we know orange isn't 3, right? Yeah, we know orange isn't 3. So in this box, 3 goes here. Guess 3 is in one of these two. What over here? We know blue's not 3, so this is 3. That resolves that, and the 5, and the 4. Blue is now not 1 through 5, and it's not 8, so it's 6, 7, or 9. I don't know how you rolled out 6. Can't we put 6s here and here? Make those blue? Okay, orange is not 5 and blue is not 5. So in this row, where does 5 go? It's none of these. And this 5 sees down. And we know the 2-5 look and say killer keeps it out of this one. So this is the 5. That's a really good spot from Josh. So that look and say is done now. So these are from 6, 7, 8, 9. Now, do I know anything about orange not being one of those? I think if orange was 6, we'd have a problem fulfilling the 2, 6. Yeah. If orange was 6, the 2, 6 look and say wouldn't work, so it's not 6. this one. It'll be out of here, and out of here, and out of here, and out of here. Wouldn't go anywhere. Orange is not 7 because of this box. Okay. So orange is 8, 9. If orange is 8, then the 2, 8 diagonal has an issue. Couldn't we just put orange, orange? Let's see what's wrong with that. Orange, orange, orange. And that breaks the diagonal. That breaks this arrow clue because we see another one up here. So we wouldn't see one orange, we'd see 2 oranges. So that means orange is not 8, orange is 9. So blue is not 9. Yeah, nice spot. Do I give this a color? We don't know it's not blue. This is a 9 as well. All right, let's get rid of the coloring then. Five, 6, 7, 8. These aren't 5s. What's this one doing? It's interacting with the 2, 6. Let's see, these are also 5, 6, 7, 8. We also have this look and say saying there's 1, 5 on this diagonal. I haven't found it yet. It's not here, it's not here. It's not here or here, obviously. There's still 4 places, 5 places for a 5. These are 5, 6, 7, 8. Yeah, just have 2 X-wings left on 9s. This is not a 7 because the 7's on the 2, 7. Okay, if blue was 6, then these 2 would also be 6. Is that a problem? I think it would prevent this from being 6, so we'd have a 6 here. And then here. Here and here and here. So 6s would finish like this if blue was 6. It seems viable. I want that to be true. Puts a 7 here and a 9 here. Hmm. This, oh, okay. So if this was a 5, this would also be the same. This would also be cloned here. If it was a 7, not as much. It would put it on the 15 diagonal, yeah. So a 5 here puts a 5 here, which puts a 5 here. Which puts a 5 here. Okay, yeah, 8's in one of these two for the column, so they're not here. So we'd have a 5 here, a 5 here, 5 here. We have this 5, obviously. So we'd have a 5 here, which would put a 5 here. We have this 5. It's a 5 here. It's a 5 here. It's all of them. Oh, now the 15's broken. True. Okay, so it can't be 5. Wonderful. Put some eye drops in. That places this 5. So there's a 5 up here. Wait, there's a 5 here. And so there's a 5 here. There's definitely a 5 in one of these two, and that goes with the 9s. Yeah, the 6, 7, 8 triple takes this 8 away. Places an 8 here. This is a 5, 9 pair. So this is a 3. Nope. I scanned wrong. This is a 6 or 7, non-blue. So let's give that green. There's a 5 up here now. That looks left. That's 9, that's 5. So that's the 9. These are 6, 7, 8. It's not an 8. These are from 6, 7, also 4. So we have, oh yeah, we need an 8 as well. Five is in one of these two in this box, which looks up, placing this 5. We now need a 5 on this diagonal. It can only go here. So that's a 9, which means we need a 9. We have one. But that's a 9. That's the 5. That's the 9. That's the 8. That's the 7. This is a, oops. This is a 6. These are from 6, 7, 8. 7 goes here. Still don't know if blue is, oh, so this is 6. Blue is 7. That's 8. This is 8 and 6, 7, 8, 6, 7. This is now 2 6s. 8, 4, 8. 6 and 7 across. 4 and 8. 6 and 8. Oh, this collapsed fast. And we're done. Correct solution. Nice. That's always a 6. Thanks, Derek. That was fun. Yeah, I think the 5s were probably the toughest part there. Well, I'm glad I had chat to help me spot that one. All right. Zeta's puzzles next. Row 2, column 11 is our bet cell. Well, I have a light queue and lots of time, so I think we're good. Yeah, it's 4 6x6s. All right. This puzzle is called Cat's Cradle. It's by Zetamath. If somehow you haven't heard of Zetamath, definitely check out his YouTube channel as well. He does Sudoku. And he also has a mathematics channel that's doing quite well, where he does mathematics videos. All right, so the grid consists of 4 6x6 mean minis. The coloring in the grid is to indicate the boundaries between these 4 puzzles. Each of these 6x6s contains precisely 6 of the digits 1 to 9, and those digits obey Sudoku rules. That is, they do not repeat within rows, columns, or boxes. The lines in the grid are region sum lines. For each line, digits on the line have an equal sum n within each box it passes through. If a line leaves a box and re-enters it, the count resets. Additionally, within adjacent regions in different grids, digits may not repeat within a row or column. For example, row 5, column 1 which is here, cannot contain the same digit as row 8, column 1, but could contain the same digit as row 9, column 1. Ooh. Interesting. Okay. Because this region touches this region, you can't repeat in the column. Interesting. Well, we got to start somewhere. Let's color this. These are the same digit. I'll call that green. We're basically done. Maybe it's this big U. I'm glad you agree, Jessica. Practically done. So green, the problem is green can repeat up here. But let's see. Green can't repeat here. But we don't even need a green in that whole puzzle. We go through every option of green. There you go. Hey Eric, how you doing? Row 7, column 2, 3 is equal to row 8, column 4, 5. As in they have the exact same digits. True. So 6x6s are always roped. So the same 3 digits go here and here. So let's say this was A, B, C. Then if I were to put, say, A down here, or sorry, if I were to put A down here, it would have to add to the same thing as B plus C. Well, is there a reason I couldn't do that? Why couldn't I do A, D? But I couldn't use B or C to do it. But we know that this is a BC pair. So that's broken. So we know that these are the same digits as each other. So these are the same digits as each other. So here we need 3 ways to add to the same number that there's 2 ways to add to. We use 6 different digits here. And 6 different digits here. I'm sure there's a way to think about that, but I don't know what it is. And these don't contain C. The giant U has to be a multiple of 6. So yeah, the sum is min 11 because 6 digits add to 21 minimum. So you divide that by 2 and you get 10.5. So, but you can't have a non-integer sum. So the sum is minimum 11. Yes, critical race theory is very important in Sudoku. I'm glad I was taught that in elementary school. All right, let's see. There's probably some really clean way to think about this U that I just don't understand. Cathode ray tube? It's a good one too. It's all we did in elementary school, true. Three A equals 2B, then A is even, B is a multiple of 3, so the sets are still a multiple of 6. The line is just saying that, yeah, this sum does not have to equal this sum, which I think is what's confusing everybody. The sum of these 6 digits is probably not the same as the sum of these 6 digits. So it's just, yeah, 2x and 3x here. So actually the sums cannot be the same, right? The sum of these 6 digits is 2x, and the sum of these 6 digits is 3x, as Derek said. So that's one way to think about it, is the set of digits used here is much larger or smaller? Is much smaller than the set of digits used here. So if let's say we use the minimum of 11 here. So if this was 1, 2, 3, 4, 5, 7, then we could make 2 11s out of that, I think. Yeah. And so then this would be 33. What's the max we could do? 98765 is 35. We can't add 3 to that. So doesn't it have to be 11? I think that's forced. Oh, 39 is max? Did I count wrong? Oh no, I just only did 5 digits. 39 is max. So it's 11 or 12 or 13. But it works so much better adding only 5 digits, Zeta. So the sum is 11, 12, or 13. Breaks the large line on the right. So if Josh's point is if this was, this was 4, 5, 6, 7, 8, 9, then these two have to choose from 4, 5, 6, 7, 8, 9, but the minimum is 11, and I can't put an 11 in this cell. So even worse, I have to put 3 digits here that sum to a single digit. So I must contain 2 of 1, 2, 3, or I exceed 9. So if I need 2 of 1, 2, 3, the minimum I can do is 2, 3, 4. Sorry, the maximum I can do is 2, 3, 6, 7, 8, 9, which is 35. Min is 11 because of this column. Because 1 through 6 adds to 21. You got to divide that by 2. So 35, but we said the minimum is 33. Now it actually works the way I said. It has to be 33. So this has to be 11, which is 1, 2, 3, 4, 5, 7. And hopefully there is 2 ways to make 11. 1, 3, 7, and 2, 4, 5, it looks like. Row 4, column 4. It's not a 1 or a 2. Okay, so there are 2 different ways to sum to this value. So it's got to be a 5 or a 7. Now, do we actually have 2 different ways to sum to 7, though? We do. 3, 4, and 2, 5. So I need 3 different ways to add to 11 here. So I'm not allowed to contain a 1, right? Because every single digit's involved in a sum to 11. So 1 is excluded. So this is a 9. No, this is a 9. Let's select the correct cell. And this has to be 2, 3, 4. So we're going to have 2, 9. We're going to have 3, 8, and we're going to have 4, 7. That's what's in this box, in this puzzle. Row 5, 6, column 5. We do have 4 cells here adding to these 2. 4 cells adds to minimum 10. So these 2 add to at least 10. So I have to put a 7 on it. Okay. So there's a 7 on here. The 7 goes with 1 and 3. So that ropes that way. And so now this has to add to 7. We got more digits. This is 3, 4. So there's a 4 over here. This is at least 10, so it's 3, 7. It's a 1. So it does add to 10. So this is 1, 2, 3, 4. I'm going to color this. We don't know it's not green, is kind of an issue, but it's okay. Digits, yay. These add to 10. Okay, out of the pool of digits I can use without using the 7, how do I get to 10 and 3? 2, 3, 5 is a way to do it. Is there any other way? I'm going to call it 2, 3, 5 unless proven otherwise. Oh, 1, 4, 5? 2, 3, 5 or 1, 4, 5. Darn it. I don't know which way it goes. Zach will dance for me in the morning. Thank you. Row 5, 6, column 9. Hey, Rise to the Equation, welcome. So out of these digits, we got to add to 9. 2, 7 is the only way to do it. Otherwise, we're too low or too high. Very nice. And so without the 2, we don't get the 9. Without the 7, we don't get the 4. So this is 3, 8. Oh, 2, 3, 4 looks left, so that's 7, that's 2. So now we actually can use our rule here that the 7 can't repeat in this row, so that's 3 and 7. And this 3 looks right, so that's 8 and 3. And so these are whatever's left. 4, 5. No, there's no 5 here. What is it? 4, 9. Then this 4 still looks over. This whole box is done, and this is 7, 8, 9. Right, that's roped. Sorry. Sudoku intensifies. Hey, sportsman, how you doing? Ah, and these two 4s do look over. That's a 5. Yeah, the rules say if the regions touch, then you can't have a value share the row. It's the last paragraph here. 1 and 3 in column 5 look down. Oh, true. Yeah, these regions touch. So this can't be 1, 3. Oh, 3, 4 pair removes 3 from there. These are 1, 2, 5, 7 for what it's worth. If this was a 2, it would resolve that. Use the 5 I just got. This 5? Ah, this 4 does look right. So that's not 4, so that's not 7. There is a 9 down here. 9 on the lower line, lower right region looks left. True, there's a 9 in one of these two. I don't know if that's what you meant, but row 8, 9, column 7. Yes, there's a 9 in one of those. And what do these add to then? So these add to at least 10. But actually, they add to at least 11 because the 1, 2, 3, 4s are used up. Interestingly, they can't be 7s. 7's not allowed in this grid. The 10 sum must have a 5. Which 10 sum? This 10 sum? Let's all scream about the 5. I don't know what. Row 5, column 6. What about it? Didn't we say there were two options? Maybe the two options both have a 5? 1, 4, 5, or 2, 3, 5, I guess. So without a 5, can we not hit 10? With 1, 2, 3, 4, 7. One, two, three, four, 7. That's to 17. So we'd have to remove 7 in 2 digits. 3, 4? No, we're not allowed to use the 7, though. Right, okay. So that's an easy way to see it. We're not allowed to use the 7, and 1, 2, 3, 4 adds to 10, so you can't remove anything to continue adding to 10. So we must have a 5 in the sum, and it goes here. Puts a 5 up here. Row 7, 8, column 6. Oh, they do see a 2, 4 pair. That's true. Let's give this a color. Why not? Ah, true. So this sum here is at least 11. So this sum's at least 11. And it can't use a 5. So 1, 2, 3, 4, 7 is 17. So we can only subtract up to 6 from that. So we must use the 7. Wait, no, we can't use the 7. Wait, what are we saying about this? Oh, it can't use... No, it can use the 7, and it must. The 7 goes here. I was scanning from here, and that's wrong. And 4, 7 is 11, right? So this is 11 then. So this is 9, 2. And this is 5, 6. Very nice. So that's the 6, and that's a 5. So that's a 5. So that's a 4. That's not a 7. This is now 2, 3. So this is 1, 4. So this is the 4, and this is the 1. So this is 2 and 4. So that's not a 2, which means that's not a 9. The scanning across the grids rule is because you found when you did not have that rule, you kept doing it anyway and having to rewind. That's really funny. Blue is in this grid. Both 1 and 3 are in this grid. So this is blue, which actually gives us the value of these. I don't know if that's intended, but that's fun. So this is 1, 2. That's a 2, and that's a 1. This is 1, 2, 4, and the 1, 2 look down, so that's a 4. It's intended, cool. This one looks up. In fact, we know what this roping is. So we got 3, 7 here. We got 1, 2, 5 here. 3, 4 looks over. So that's 7, that's 3. So that's a 1. This is 7 and 3. Let's see if we can finish as much of this grid as we can. That's not a 1. So what's left here? We know the roping. So we know this is 2, 5. And we know this is 1, 7. So that 7 looks over. That's not a 7, so that's not a 4. This is a 2, 9 pair. So we actually finished those. 2 5 pair places 1 here. I don't think these 2 5s are resolved. And I'm going to be honest, I think that by uniqueness that forces that to be a 2, but I'm not going to use it. Row 7, 8, 9, column 8. Well, we're over here. Okay. Must be 1, 3, 5. There cannot be a 2 on it, so there must be a 1 on it. And there must be a 3 on it. Yeah, 1, 3, 5 is the only way to make 9 without a 2. That's definitely true. That's not a 1, that's not a 3. 5, 6 pair also looks over, so that's a 1. This is whatever digit this has in addition to these numbers. So I guess we could say 1, 2, 3. This could be 4. No, it can't be 4. Can't be 5. So it's from 6, 7, or 8. It's not an 8. It's from 6 or 7. That's interesting. So these two add to 9. And I think that means we have to do 3, 6. Out of all these numbers, how do we get to 9? Can't do 1, 8. Ooh, we could do 2, 7. So we're 2, 7. Ah, but this cell C is 2 and 7. So we're not 2, 7. We could be 3, 6. We're not 4, 5. Okay, so this is 3, 6, and this is a 6. That's 3 and 6. That's not a 3. This scanning is pretty fun, actually. Oh, yes, this 2 does look down. Oopsie. With chat's help, of course. These add to 11. How do we add to 11 with these numbers? One, 3, 6 would do it. Nope, 1, 3, 6 is 10. 2, 3, 6 would do it. One, 4, 6 would do it. Okay. Hey, Andrew Sarkis, how you doing? A 4-grid Y-wing? Ah, that would have been fun. There's a 6 down here, there's a 3 down here. I keep going, oh, there's a quad left here. These add to the same as these. Does that mean these are 11 as well? True, we do know all the digits now. The green is not 1 or 6. So it's 2, 3, 4, or 5. Box 4 of grid 4. Time to good lift every cell? I might good lift these. 2, 5, and 1. This 2 looks down. Three digits adding to 4 digits out of this set. So it's minimum 10. Well, hold on. 1, 2, 3, 5 is the minimum, which is 11. I don't think we put a 9 in this quad sum, can we? If we did, 1, 2, 3, 9 is 15. Can we make 15 with 3 of our digits? We could. 9 and 6 by itself is 15. Darn it. Ah, you can corner mark 2s here, which looks up, putting a 4. Nine is on it in box 4. True, there's a... Wait, do we know that? Ah, okay, yeah. Well, no, what am I saying? I don't know what I'm saying. We know the roping here. This is 269 and this is 135. Three in row 7, column 10. C's left. True. Row 11, 12, column 6. I see. So this maxes out at 11. And this is minimum 11. Got it. So this has to be the 2. 1, 2, 3, 5 is 11. This is 5, 6. So this is 2, 4. We know this sum is 11 as well. That's 6. So this needs to be a 5. 6 and 5. So these are 1, 3, 6. That's not a 6. Green is not 5. Row 10, 2 looks left. True, it does. That's a 4 and a 2. Guess this is 1, 2, 3, 4. This 2 now looks right. That's true. That's 9 and 2. This 3 looks here. These ones, oh no, sorry, these ones can't point to here. That's not, it's too far away. 2 looks right again. 2, sorry, I don't know which 2 you're talking about. So 2 down here. Wait, no, it can't be. Oh, I was looking at this 2 and looking down, but it's not true. There's a 2 down here on the sum. Row 8, column 7. Does look right. That's a 5. Nice. Now we know the roping. So this is 169 and this is 235. We know all these pairs. This is 1, 2. This is 3, 9. And this is 5, 6. We know 3 and 1 go together because of this 2, 3. Row 10, column 8 sees a bunch. It sees this one. Sees those. So this sum is 15. So this is also minimized. Can't put a 9 on it. Can't put a... Wait. We have to put a 6 or a 9 on it. All right, no, minimized is not... Minimized is 11, not 15. But the outies, true. So we have 1, 2, 3, 5, 6, 9. So that's 11 plus 15, which is 26. And these add to 15, so these have to add to 11. 5, 6 would work. That's it. Certainly can't have a 1 on it. Nine would require a 2. So this is 6 and 5. Cool. So these add to 11. I don't know how to do that. Or rather, there's plenty of ways to do it. 6 looks left, thank you. Continues to look left. That's not a 5. This is a 1-3 pair. That affects this cell at least. I had to double check that that was valid, but I'm pretty sure it is. It does not affect this one though, because this cell does not affect this cell. This is a 5. So there's a 5 over here, which at first I thought was broken, but it's not. So there's a 5 on my 11 sum. So the other 2 add to 6. So 2, 4 is the only way to... No, there was no 4. Wait. No, they add to 15. So the other 2 add to 10. How do I get to 10? I could do 1, 9. What else could I do? There's no 2, 8. There's no 3, 7. There's no 4, 6. Okay, so it's 5, 1, 9. That's not a 9. That's not a 5. So this is the 1. 5, 9 sees left. These are the remaining digits, 2, 3, and 6. So the 2 is placed. 3, 6 looks left. That's 1 and 3. That's now a 3. These are not 3s. Oopsie. Yeah. These are not 3s. That green isn't a 3 because of this 3. So you're green, you're purple. You're not a 2 or a 4. 1, 2, 4. So that's a 3. Doesn't quite see that. Three's in here. Okay, well, we know the roping here. This is 1, 2, 5. So that's the 1. This is 3, 4, 6. This is the 6. Ones go here. 2s go here. 3s go here. 4s any of these. 5 and 6. So 5 goes here. 5 goes here only. So 1 goes here only. And then 6 goes in here only. So that's a 4. These are 2s. That's a 4. That's a 3. I really hope I did that right. because that felt a bit strange. I think that grid's done though. This 3, 2, 3. All right, we still have this grid up here. This 2 is seeing all, okay, 2 is seeing all of these, so that's a 2. So what's left here? We've got, okay, I have to refamiliarize myself. We've got 2, okay, 3, 7, 8, 9. This is not a 7. That's not a 7. So the 7 has to go here. Oh, and 9's already in the column. And what are these for? So we have a 2 and a 7, so we need 3, 4, 8, 9. 9s can't go here. This 4 sees over, so that's the 4. This can't be 4. Sven not helping with the puzzles, true. What was Mark's point? Row 12, column 12. Does see up, true. I think that resolves this whole thing. All right. This 9 does see up. Almost done. Still have to fill a 2 here to finish this grid. Let's see. I'm gonna good lift the rest of this. Should I? 2, 3, 4, 7, 8, 9. Right, 7 and 4 can't go here. 3 and 8 can't go here. 2s don't go here. This whole column can't be 4. This whole column can't be 2. This whole column can't be 3. Did that help? I don't know. I don't see how this could be a 2, could it? No, yeah, we could do 3, 8, and 2, 9. I don't know how much that helped. Gotta be this line then. We add to, I mean, we could even add to 17, although I think that would immediately make a deadly pattern. Oh, this can't be a 3. Does that help? So the 3s are down here, so none of these are 3s. The 2 next to it sees left in row 3, column 8. Ah, this 2 sees left. Aha. So we did not need a 2 here. This 2 actually resolves the 9 and the 2 here. What a twist! How did we not see that? All right. True, this cannot be 3, 8. It breaks this cell. Good point, Jessica. So we're either 3, 9 or 8, 9. So we have to use a 9. We must use a 9, but we do that from Sudoku. Column 10, we already have 7, 9, 7, 8, 9. True. So only one of 7, 8, 9 can be on here. Okay, so only one of 7, 8, 9's on here. So there is a 2 or a 3 on here. So this must be a 3. So it is 3, 9. That was a very good spot, Laszlo. I think that cracks it. These are not 9s. So these add to 12. I can't do 7, 4. I can't, sorry, 7, 5. I can't do 8, 3. Wait, that's 11. I can't do 8, 4. So we're just 9 and 3 this way then. And it's not a deadly pattern because of this 3 here. Okay. Can't use any Sudoku tricks in this puzzle. This is a 2. I think we're done. But Sven's not helping, and I don't know how to function without Sven anymore. Let's see. It's an 8, 7, 9. Oh, come on. Wait. What did I do? Oh, the 8. It was so far away. How was I expected to see that? This 4. Nice. Cool puzzles, zetamath. And it didn't even take an hour. Maybe Sven needs to add first-class support for multi-grid puzzles in some way. I don't know what that would look like. All right. We have more puzzles, thankfully. This will be the last puzzle of the stream, and then we will do word games. And then that'll be the stream. And it's Panthera's puzzle. For this one, I will turn off the row column labels, and I will switch scenes to my outside grid scene. Okay. Good night, Zeta. Thanks for staying up. Hey, Michelle. I am kind of left, aren't I? Can I be less? Oh, it's because this webcam capture is different. So let me do this. Let me delete this webcam capture. Uh-oh. I think I crashed it. Oh, no. Are you sure you want to remove? Yes. I'm going to copy this webcam. I'm going to paste it in here. Move it back down. Okay. Looks good. All right, this puzzle is called Down Under Camel. It's by Panthera. Standard Sudoku rules, standard Japanese sums. All right. Do we just pick the color? I pick green, and then we'll use gray for unshaded. Good night, Jim. All right, 36 plus 7 is what? Wow, my brain. 43? So the outies are 2. So all of these are green. Oh, no. The outie of 2 is in between them. So these are green. 36 is at least... Okay, it's like this. That's what's happened. This is a 2. That's a 7. Good start. All right. No? Oh, right. It doesn't have to be like that. That's true. Hold on. Ah. Give me a sec. 36 is at least how many? 9, 8, 7, 6. That's 30. 5 is 35. So it's at least this long. Okay. So the 7 can't reach over here. Neither can the 8. Can't reach here either. 17, 1, 2, 3, 4, 5, 6. 17 can reach all the way. But 14 doesn't fit here. Even if this was the 13, it wouldn't reach here. Oh no, but the 7 would fill there. Never mind. My brain is not functioning correctly. All right, 21 needs to be at least 3. $32 is at least 5, true. So even if it went all the way right, it still has to take this one. And this is the 32, because we can't fit 32 over here. This is part of a 14, which is max 4. So that's not shaded. That's not shaded. It has to take this one? Really? Why? Because if it took only the ones to the left, it would have to take 5. There'd be no room for the 7, because we need a blank in between. So it takes this one. Is there any universe where this is a 7? I mean, this could be a 7 and these two get out to 13, so I suppose so. True. This can't be the 7. This is part of the 13, because you can't do... Sorry, it's part of the 30, because you can't do 30 down here. I don't know which way it grows. Let's see. We could do 7 blank, and then the 30 could start here. So 1, 2, 3, 4, 5. So it always takes these two. No, 4, sorry. It always takes this one. The 2 clue in this row means the outie can't be here. So this is the outie of 2. Okay. Good point, Laszlo. Oh, I did it upside down, you're right. 7 blank 30 could start here, so it always takes this one. $15 to 5 9. Oh, these are all gray now. And 17's at least 2 cells. Mm-hmm. True. If we did the minimum 7 blank and then 4 cells here, that wouldn't work because the 7 would be used. So we couldn't use it in the 9876. So I think that does prove that we always take this one. Because either it's 7 blank and then a 5 long, or we start higher up. So this is the 16 clue, so it's at least 2 long. This can't be 8 9. If this were 8 9, then the 7 clue would be too big. So yeah, that grows one more. Right. This can't be the 7 clue anymore because it blows out this sum. So this is the 13 clue, and it's at least 2 cells long. That means the 30 clue extends down here. This is the 30 clue. So we didn't need any of the logic about these cells because this would have done it. Okay, so this is not the 2 clue. This is the 12 clue. And the 2 is going to be by itself. So the 2 clue can't be here. So the 2 clue is going to be over here somewhere. So there's a 2 over here. This couldn't be the 2 clue because couldn't be the 1 and it couldn't be the 7 because there'd be no room for the 1. So the 2 clue is one of these two. This is a 2 up here. What am I missing? Row 2, column 4, definitely shaded by row math. Not sure what you mean. Oh, you mean unshaded. Yeah, so the 2's over here, and the 12 can't do 12 and 4 without the 2, because 3, 4, 5 already adds to 12, so yeah, that's not shaded. Same here, true. Gray is unshaded. You can just say green and gray, yeah. Right, this one's gray, definitely. Mark asks if this can be a single 6, but I don't see why it couldn't be. It forces a lot if it is. I'm not sure what you mean. Okay, yeah. If this was a 6, we have to make the 7 clue, so this would be a 1, but then that breaks this column clue, because this would have to be a 5. We're not allowed to shade a 5 in this row. So this is not shaded. I don't know what that did. There's no 2 in here, so the 7 is not in 3 cells. Oh. Yeah, 1, 2, 3 breaks because we need a 3 later in the column. True. I feel like we're missing something important. Okay, so Ice Cube's point is any shaded cell over here is either a 1, 2, or 3, but not a 2. So the 3 clue is a single shaded 3. So if I'm shading anything in this row, it's just one cell and it's a 3. And actually, where does that go? It doesn't matter. So what happens if this is the 2? This is the 2. I need to make 6. And I can't do 1, 2, 3. So I'd have to do 2, 4. And I'm not allowed to put the 4 here. So the 4 would be here. But now how do I make 7? I can't use a 2, so I'd have to do 4, 3. But that one clue breaks with a 3 shaded 3 here. So this is not a 2. This is the 2. And that's part of a 14 clue. This is maximum 7. That's only 9. So this is green, and so that's the 3. So now we have 5, so we need 9 more. So even with this shaded, that's only 7, so we need this as well. So this is the 11 clue then. But if, okay, yeah, if this was a single 7, these would add to 12. I need another 2. That doesn't work. So this can't be a single 7, which means this one's always green and it's a 1. So, no matter what, I'm putting a 6 in one of these two. It would really make sense here, wouldn't it? Oh, this can't be a 6 either, because we'd repeat the 3. So, or do 1, 2, which also doesn't work. So this is not shaded. This is a 6 and it's green. Can't put 14 in a single cell. Can't do 9 and 3 with a 2, 3 missing, so that's not shaded. Says Afraid Night. What do you call a camel with 3 humps? Pregnant? Good thing there's a Sudoku vet to help deliver. Where's Philip? All right, so camel with no humps, hump free. I'm stuck again. Why can't it? Okay. So this can't be 1, 6 because it sees 1, 6. It can't be 2, 5. So this is 3, 4. Good point. Glad we're making progress on camel jokes. True. This couldn't be a single 7, but I don't know if that matters. I feel like this is 9 as well, but I don't know how to prove it. Not yet. Okay, I don't think this can be a 5. Can it? Because these 3 would then add to 8. We'd have a 2 in there, so it would be 1, 2, 5. That doesn't work. So this is not shaded. Could be the 2 still. If row 2, column 8 is gray, then row 1, column 8 is also gray, because we can't fit 15 there. That breaks the 13 and 12 clues for the row. So 13 would be 4, 9, and then 12 would be 3, 9. Yeah, that is broken. So this is green. Nice, Garion. We have 12 and 3. So these add to 8 or 9. Somehow. About 16 here. Wow. Not sure. Using your logic of 2 different 9 sums in box 4? Well, okay, so this is either a singular 9 or these 2 add to 9. So 1, 8. Well, this can't be an 8 because then this would have to be a 1. So, oh yeah, these add to 9 and these add to 9. That's true. Wait, isn't that just broken? Oh, can we do 9 and 3? If this extended down, then this would have to extend right twice. We'd have to do 9 and 3 this way and then 9 and 2 this way. So this is either a singular 9 or this extends down and this extends right 3. So it would be from 1, 4, 5, or 6 just for this sum. For this sum, we couldn't do, well, could we do 1, 8? I think we could do 1, 8. 4, 5, or 5, 4. Can't do 6, 3. Yeah, this cell equals these two if it extends. Why does one break the row 5? 1 breaks row 5? Oh, 1 would put an 8 here, and this is a 7 clue. True. So if this extended, this would be a 4 or 5. So this would be a 2 or a 3. So we'd have all of 1, 2, 3 in these cells. Sorry, in these cells. All of 1, 2, 3 in these cells. Try 4, it quickly breaks. If that's 4, then that's 5. And then these two add to 5. Right, so if this is 4, this is 5. These two add to 5. Couldn't do 1, 4, so it would be a 2, 3 pair. But then now this is a 7 clue, and we can't use a 4. So, but we can't use 5 either, so there's nothing to add to 7 with. This would be a 4 or 5. So, not a 4. And then 5, 4. These two would add to 4, so it'd have to be 1, 3. This would be 3 and 1. And then now how do we get to 7? We can't do 1, 2, 4, so we'd have to repeat the 4. Okay. I think it's just a matter of not having enough low digits, but anyway, that's a 9. So these are shaded, or unshaded. Better start the 7 soon, or it's going to run into that. Okay, how far can 11 reach? I don't think 11 can reach here. Right. Okay. This obviously, if this wasn't a single 7, then these two would be shaded, adding to 7. And then we can't. Then that means these two would be shaded, adding to 7, because we can't do a 3. But then these two would be the same digit by definition. So this is just a single 7, and these are unshaded. So now we just put a 3 here. We shade it. That connects up to the rest. 6, I think, can reach any of those. Stop. Because you need an unshaded cell in between the clues. I need a gray in between the 2 blocks of greens. Okay, I've got 18 left. You can do 18 and 3. Okay. Should I look at the outies on this row? Because 32 plus 7 is 39. So my outies are 6. So if I have another gray, either here or here, that's all I get. This one can't be gray. Can these two add to 6? I think these two could just add to 6 on their own, though. We could do 1, 5 or 2, 4. But if they didn't add this, so these could be 1, 5, or sorry, whoa. These could be 1, 5 either way, or 2, 4 this way, or they'd be a 1, 2, 3 triple with the other gray. The 3 is used, so they'd be 1 and 2. So this would be the 1 and this would be the 2. So these are actually all it can be. Um, 21, 1, 2, 3, 4, 5. Can only go 6 long. Yeah, can't reach here. The camel's taken shape. In fact, it feels almost done, if not completely done. Row 3 column 8 is already green. Row 6 column 8. Oh, now I can't see what your message was. Yep, the camel row. Down under camel. If row 6 column 8 is green, then green is 1, 2, 3, 4, 5, 6. True. Where do the 7 and 9 go? Ah, yes. So if this were 1, 2, 3, 4, 5, 6, I need a 7 and a 9 in the row, and they'd both go in this cell. So this is not shaded. Nice. If row 4 column 8 is green, then the kangaroo looks wrong. No. Then the 5 clue in the column must be in row 7 column. Yeah, okay. True. So if this were all 15, then this would have to be the 5 clue, but you can't put a 5 clue in a 3 long 7. So this is not shaded. Funny looking koala. So that's a 5. Whoopsie. So we still aren't quite sure how this works. There's outies. I suspect that this is a shaded 3. Well, if this were an unshaded 3, I mean, if this were shaded, you have to make 5 and 2 this way. Row 4, column 9. True. This is gray because you can't put a clue there. Right. This can't be shaded because it would have to be a 5. One of these is a shaded 5. Does it have a long mouth or a long foot? We now have the row 5 outies. That's a 3, that's a 2, that's a 1, and this is shaded. Might as well fill these. 4, 6, 8, 9. Let's see, 4, 5, 6 is 15, plus 17 is 32. This can't be 4. Oh, hey, Panthera, I thought you'd be asleep. Oh, column 4 clue is a 6. And it's no longer 1, 2, 3, so that's not shaded. Can we do 4, 2? I don't see why not. But these are not going to be shaded either. Oh, it is too long. 4, 2. What am I talking about? Can't do 6, 0? Watch me. Watch me. There. Exactly. What kind of attitude is that? Let's see. With 5 on the grid, let's see. 21 minus 5 is 16. I'd have to do 9, 7 here. I mean, it's doable. Darn. There's 1 0 hidden in the grid. Rules don't say there's not a hidden 0. Yeah, you should put that in the rules next time. You don't want us to use 6, 0. Let's see. Come on, what am I missing? Wait, this is a 9 clue. Okay, that's okay. 15 would be 6, 7, 8, 9. Where are the doubler cells? Good question. What am I missing? Claudia has a lot to say. Oh, I'm not sitting correctly. I really should sit correctly. Under the camel. An interesting observation, at least, is if this was the shaded 5, these would add to 11, and the only way to do that with 2, 3, and 5 gone would be 4, 7. But, I mean, it works. Okay, so this always has a 7 then, because this is either 9, 7, or it's 4, 7. So it has a 7. Deduction of the year. And if this didn't grow upwards, it would have to be 9, 6, or 7, 8. Oh, which means this cannot be... Oh, sorry, it's part of a 13 clue. What am I talking about? It's late. Okay, if this was if this didn't grow... Hold on. Yeah, if this didn't grow, this is a 9 and that's a 4. So if this doesn't grow, this must grow, because we don't get to use the 9 down here. Hey, Finland. No, I don't do GeoGuessr on Thursdays. So this doesn't grow, this is a 9. If it does grow, these add to 9 or 10. So either this is a 9 or these add to 9 or 10. So if we wanted to add to 9, can't do 1, 8. Can't do 2, 7. Can't do 3, 6. Why am I adding? Yeah, I'm adding to 9. 3, 6. It would be 4, 5, but the 4 is used. I actually can't add to 9 and 2. So if it grows, this is a 3, and these add to 10. I can't do 1, 9. 2, 8 looks possible. Can't do 3, 7. Can't do 4, 6. Wow. Okay. Does that help? Claudia, what's going on? What's going on, Claudia? She's so vocal. I don't know how to tell the difference, though. Well, okay, so we know what this ends up being then. This ends up being 2 or 8. If it's shaded. So we'd have 4, 7, 5, 2, 8. Claudia. I don't know what's going on. Clue. Okay, so if this was 3, 2, 8, if this was 3, 2, 8, this would be 4. These two, okay, this would be 5. This would be 4, 7. And this would be green. So let's just look at this. How do we add to 12? Wait, that's not how that worked out, right? No, I don't think that's how that worked out. I did something wrong. I think 3, 2, 8 doesn't force this to be 4, 7, does it? But if this is 3, 2, 8, this is 4, these add to 8. Can't be 1, 7. Can't be 2, 6. Could be 3, 5, I guess? It would have to be 3, 5. Which would then force this to be 7, 9. So actually, if this is shaded, this is not shaded. Goodness. What's up, Claudia? If this is 4, 9, this is 4, 7, 5. Now, this would be a 3, so these would add to 9. I could do 1, 8. Could not do 2, 7. Could not do 3, 6. So I'd be 4, 5. Did I roll out 1, 8? 1, 8 or 4, 5? What's wrong with 4, 5? Oh, this would be the 5, though. Wouldn't it? This was 4, 9. This would be unshaded. The 9 would have to be used. This would have to be 9. Wait. How big can this be? I used the 4 in row 3? Right. Would I? If this is 4, 9. Ah, this is 4, 7, 5. Right. Because the 9's used here. So then this couldn't be 4, 5. This would be 1, 8. So this is either 1, 8 or it's 3, 5. So yeah, this 6 looks over. So 6 is one of these two. Exactly one of these two is shaded. And we know what the sum of all the shaded cells is. So 13 plus 12 plus 16 is 41. How'd you get 53? Okay, so 41, we already know that 7's accounted for. So it's 34 in 6 cells. $34 in 6 cells. We know it contains a 7 also. So 27 in 5 cells. We know exactly one of these two is shaded based on the cases we went through. I didn't realize this would take so long. So 27 in 5 cells. Without a 6 or 7. Doesn't seem... $30 clue? My testers said this one was normal length. I wonder what they found that I didn't. Three's in one of these two. I wonder if the 15 comes into play here. If I want to do 15 and 2, I have to do 9, 8. Or it's not 9, 8, 7, 8. So it would be 7, 4, 5, 8, 1, 8, 1, 3, 4, 9. Ay. Okay, what about in 3? If that was a 9, can I make these add to 6? Not with 3, 3. Ah, since the 3 is in one of these two, I cannot use the 9 here. So it would have to be 9, 3, 3. Or missing the 3 entirely. So that's never a 9. Give me one moment. Sorry about this. Okay, I'm back. We don't have a whole lot of info about this box is the issue. I don't even know what to try. You think it breaks the 8 clue? Why can't this just be an 8? This is a 5, it's shaded. And these add to 12. Means at least one of these, that's true, one of these must grow upwards. Otherwise it's 9, 7, which adds to 16. That's too big. So at least this one would be green and part of the 8 clue. If this was a 9, these would add to 14. These two would add to 3. So it'd be a 1 here and a 2 here. Doesn't that break box 3? Maybe not. How do you make 7? Can't do it in 3 because there's a 3 down here. So this would be a 1 or a 2. So this would be 1, 6, or it would have to be 1, 6. Okay, so then this would be a 2. Oh, this couldn't be a 2. So if this was a 9, this would be a 1, 2 pair to complete. This would be a 1 and this would be a 2. To make 7, this would have to be a 5, and it couldn't be. Okay. So this is not a 9, so then this grows as well. So what's wrong with this then? There's a 1 in here. Did you see how this one would break, the 8? So there's always a 1. What options? If it was 1, 2, then we'd have 1, 2, 5. So this would be the 5 with a 1, 2 pair. This would have to be gray because we can't make 7 and 3 anymore. This would be the 1, and then we'd have to have a 2 over here. So to make 9, we'd be 1, 8, or 2, 7. These add to 12, right? So this would be at least 3. From the 16 clue? What's the 16 clue? I don't know what's happening. What am I trying here? I know these add to 12. Well, we already tried up here. There's 2 viable options. That's why we spent probably half an hour on just this one box. So now we're trying this box. It didn't break when I tried it. The 7 would have to be 16. The 7, the 9, what are we talking about? Okay, these add to 12. So if this was a 7, then these would add to 5. So they could be 1, 4, or 2, 3. But that's not big enough to make this 7 clue. So this 7 clue would grow, and it would... Is the point that this is too low now to make this 7 clue work? Because this can't grow it because it needs to use a 3 somewhere in the column. So this would have to be 6 or 5. This would have to be 6. So these two would add to 6, and they can't. Okay. So through the insaneness of all that, we've proven this can't be a 5. So that's a 5. Now, how did we do this box with that being a 5? That's a 6. Right, we didn't prove 1, 3, 4 also breaks. Shoot. If this is the 5, these would still have to grow up. 1, 3, 4. This would be the 1. This would be 3, 4. So this is definitely blocked because you can't do 7 and 3 here. So this would be, so now to make 7, we need another 3, 4 in the box. So that's broken. Okay, now we've proven that that can't be 5. So this is a 5 and that's a 6. This is shaded. I think this would have to be 1, 8 now. This adds, okay, this adds to 9 or 10. We can't add to 10 anymore. So these add to 9. That places this 3. That's 4 and 3. This is the 9 by itself. Okay. And this is a 2. Right, now what? These add to 15, so they have to be 7, 8. Easy as cake. Okay, can I do 9 and 3 is the first question. 2, 3, 4 is gone. 1, 3, 5 is gone. 1, 2, 6. What's wrong with 1, 2, 6? I think it's just that these can't both be 3 long. If these were both 3 long, they'd both need... Oh, it would be... Hey, Kenny. How do I easily prove these can't both be 3 long? Well, the 7 would be 1, 2, 4. So this would be the 1, this would be the 2, this would be the 4. And then the 8 would have a 1 here, and these two would have to add to 7. This would be a 5 with a 2. No, it wouldn't work. Okay. Because the kangaroo would have huge feet, true. So that means this one's definitely not shaded. Because if this one's shaded, then that forces that whole square to be shaded. So now, can we do 9 and 2? Can't do 1, 8, 2, 7, or 3, 6, or 4, 5. Okay, so the 9 is by itself. So now these two add to 8. Okay, what about 7 though? Should we look at 7? 7 and 3 is not possible. 7 and 2, we can't do 1, 6. It looks like 2, 5 is possible, but not 3, 4. So this is 2, 5 or 7. How would I rule out 2, 5? If this was a 2 or a 5, the 2 would go with a 6 here. The 5 would go with a 3 here. Okay, so this would be... This couldn't be a 2. Sorry, this couldn't be a 5 because this would be a 3. Oh, what if it grew 3 this way? 1 and 2? I'm not sure. Column 6 helps. Column 6 helps. Well, let's look at the 30 clue. So these add to 14. So if this stopped here, these would have to add to 16. And you can't do that with a 6 or an 8 by itself. So this grows. So now this one has to at least be unshaded. So that there's a... Because otherwise... Wait, no, that's not true. This cell's not part of the 7 clue. But we already knew that. Let's just fill this. Maybe not. Nine can't go here because of the 8 sum. 8 can't go here because of the 8 sum. 7 can't go here. Well, no, we could do 7, 1 this way. Nine in box 6 is placed, true. So I think that places 9. Oh no, 9 is one of these two. Oh no, this can't be 7, 8, or 9 because of the 7 sum. So 9 is placed in this column. Oh yeah, 8 and 7 are possible if they're single. Okay, so what can we actually do to add to 17? So if this was 9, 2, that's 11. Then, so 9, 2, 11, we'd want a 6 here. 9, 5 is 14. We'd want a 3 here, but we couldn't. So we can't actually do 9, 5. And then 9, 7 is 16. We'd want a 1 here. This can be a 2, can't be 3, 4, 5, could be 6, 7, or 8. This can't be 1, 2, 3, 4, 5. This is 6, 7, or 8 also. So these add to at least 13. So we've got 14 plus 13, 27 already. So this has to be a 2. So that's a 7 on its own. Now these add to 16. 16 plus, so 20, 30. So 30 is done. So these are a, oopsie, these are a 3 and a 5. Yeah, if we want to do this, this is 1, 6, and this is 8, 9. Right, these add to 16, so that's a 1. Clear out those 1s. 11 clue. Can't do 11 and 2 anymore, so that has to grow. These add to at most 8. Does that help? Hold on. These add to 9. So we could do 8, 1, 7, 2, no, 6, 3, 5, 4, no. 6, 8 pair. This is 1, 3, 5, 7. Row 8, column 5 is gray. 14 clue can't reach that low. So this is minimum 10. And there's no 1 down here. Okay. So this is gray. So that's an 8. That's a 6 and an 8. 6, 8. Let's do this box. 1, 4, 7. So the 7 is placed. This is a triple now. 1, 4, 8. I'm gonna have to apologize to the word game people. I'm not doing word games tonight. 2, 6. It's not a 7. What do these add to? So these add to, this is 13. So these two need to add to 8. Can't use a 5 with that. It has to be 7, 1. What do these add to? Not enough. Right, that has to be a 2. Well, our camel's done. Should just be Sudoku now. One, 2, 3, 4, 5, 7, 8, 9. One, 2, 3, 4, 5, 7. 4, 5, 6, 8. Three, 4, 6, 7, 9. Apparently that's a naked 4. I believe it. None of these are 4. 7, 9 pair. Something's weird here. I guess that's just an 8. I'm gonna spend the heck out of this. These can't be 1s. Just for expedience, this is a 5. This is a 6. Oopsie. Follow the red. And we're done. That was tough. I feel like I might have just missed something important because that was a lot of case testing like throughout that mid section of the puzzle. So I'm sorry, Panthera, for making a mess of it. But we got it done. This was the longest puzzle of the stream, surprisingly. Did not expect that. It ate into all our word game time. I'm really tired, so I'm just going to end stream. I'm not going to do word games. So thank you, everybody. Sorry about that. We'll do word games again Saturday evening. Thank you to my super supporters, The Asylum, Peter, David Ratner, Sotek, Franco, Jonathan, MathGeek, Kenny, Aiden, Logan, Woofer, and Rise to the Equation. Thanks to all my members and patrons. And other than that, no stream tomorrow, but I'll stream more Sudoku Saturday morning and word game Saturday evening. So see you at one of those, and have a great night.